When you watch a really good stage illusionist, your brain just completely betrays you.
Oh, totally.
Like you see the magician saw someone in half, or they make a whole train car just disappear into thin air. And for just a split second, your brain overrides all of your logic and goes, well, I guess the laws of physics are just suspended today.
Right. You just buy into it.
Yeah, it has to be a trick. But the performance is so flawless, so visually perfect, that you completely buy the illusion.
It's a very humbling moment when you finally get to go backstage, though. You see the hidden mirrors, you see the trapdoors, the intricate compartments built into the floorboards.
The mechanics of it all.
Exactly. Suddenly you realize it isn't magic at all. It's just incredibly good engineering.
Yeah.
It's mechanics, rehearsed perfectly, and dressed up to look like a miracle. And, we easily let our perception of something profound be hijacked by something that is, at its core, just a very well-executed routine.
And that feeling like that massive gap between the miracle on stage and the mechanics backstage, that is exactly what we are getting into today. So welcome to the Deep Dive.
Glad to be here.
Our mission today is to cut through what has become, honestly, an exhausting and incredibly noisy debate about artificial general intelligence, or AGI. You have one side screaming that it's going to cure all diseases, solve climate change, save civilization.
Right, the techno-optimists?
Yeah, and then you have the other side shouting just as loudly that it's going to literally end the world.
Yeah.
But we are going to look at the one fundamental question that almost everyone in this entire debate is completely ignoring, which is, what does AGI actually mean?
It's the glaring blind spot of the entire tech industry right now, honestly. We're arguing endlessly about the consequences of a thing without, actually agreeing on what the thing is.
Right.
Most public claims about AGI are just philosophical postures pretending to be technical predictions.
So to help us navigate this, we are drawing on a really thought-provoking article. It's called "Simulating Expertise is Not Building It"
by Momen Ghazouani.
Right, the chief scientist at Settler Uplumda. And for you listening right now, the goal of this deep dive is to give you a customized mental model. Because the next time you scroll through your feed and see a flashy headline about some terrifying new AI breakthrough,
Which happens every week now.
literally every week, you are going to need tools. We want to give you the exact framework to know whether what you are looking at is genuinely groundbreaking intelligence, or if it's just a brilliantly dressed up illusion.
Because the illusions are getting very, very good. If you don't know where the trapdoors are, you will absolutely be fooled.
Okay, let's unpack this. The author points out that if you ask 10 very smart, serious people in the tech world to define AGI, you are going to get 10 completely different answers.
At least 10.
Right. And worse, they will probably completely contradict each other. But nobody seems to care because they're all too busy arguing over the timeline of when we'll actually get there.
Right, it's wild.
To me, arguing about AGI timelines right now is like, imagine your neighborhood is up in arms, holding town halls, arguing over whether a new, highly experimental car is going to ruin local property values and destroy the roads. But nobody has actually popped the hood to check if the car even has an engine yet. We are arguing about the impact of the car without understanding the mechanics of its propulsion.
That's a great way to put it. And to understand those mechanics, Ghazouani says we have to look at how AI actually operates today.
Right.
Which brings us to the core definitional fault line of the article, which is the difference between simulating expertise and actually constructing it.
This is a huge distinction.
It really is. And the article uses a fantastic example to illustrate this, which he calls the VS Code test. Now, VS Code is a hugely popular tool that software developers use to write and edit code.
Millions of people use it.
Millions. So imagine we have an AI system, and it has been trained on an absolute ocean of human-written code. It has ingested every GitHub repository, every Stack Overflow forum thread, all the official documentation.
Probably thousands of hours of recorded sessions of human developers just typing, too.
Exactly. It has absorbed the total sum of human knowledge regarding this specific software tool. Because it has seen all of this, when you ask this AI to use VS Code, it is flawless.
It's like magic.
Right. It uses the right keyboard shortcuts. It suggests the perfect extensions. It can diagnose a broken configuration file way better and faster than a human junior developer.
Yeah.
It looks like absolute mastery. It feels like magic.
Well, and this is the trapdoor, right? What's actually happening?
What's fascinating here is what is actually happening beneath that surface level mastery. According to the article, this AI isn't actually, figuring out VS Code. It isn't encountering a tool. building a mental model of how it functions and solving a problem from scratch. What it's doing is reproducing a pattern that millions of human beings already figured out, painstakingly documented, and uploaded to the internet long before this AI even existed.
So it's just pattern matching.
Right. It is experience simulation. The AI recognizes the situation it's in, matches it to the millions of examples in its training data, and outputs the next logical step based on statistical probability.
It's the backstage mirrors. The human developers built the trapdoors 10 years ago on Reddit, and the AI is literally just stepping through them.
That is exactly it. Now, the author is very clear about one thing, though. Simulating expertise is incredibly economically valuable.
Oh, for sure.
If an AI can fix your code instantly because it memorized the solution from a forum post from 2018, that is highly useful. It saves you hours of a headache. But usefulness is not the same as general intelligence. Simulating expertise is just a highly sophisticated form of retrieval and pattern completion. It's a category error to look at that simulated fluency and mistake it for the capacity to construct new expertise from scratch.
Because the system was never actually tested on anything new?
Exactly. It was tested on a domain that humans had already exhaustively mapped out for it.
So if the VS Code test is effectively like an open book exam where the AI has already memorized the answer key, we need a test where the answer key doesn't exist.
Right.
How do we test a system on a completely unmapped domain? To find out what genuine construction of intelligence looks like, we basically have to strip away the training data.
We have to force it to actually think.
Yeah. So let's ground this in a real-world scenario for everyone listening. Imagine you just started a new corporate job, you show up on your first day, and your boss hands you a laptop with a piece of internal enterprise software.
Oh, the worst kind of software.
The absolute worst. It's clunky. It's a gray DOS-looking terminal built in-house like 15 years ago for a highly specific, totally unglamorous, purpose-like routing regional supply chain invoices or something.
And there's no manual for this thing.
None. There are no YouTube tutorials. There is no Reddit thread you can consult to figure out what the, process optimization button does.
Because it's completely internal.
Right. It is entirely absent from the public internet, which means it is entirely absent from any AI's training data. It did not exist to the AI yesterday.
So if we hand this completely undocumented, obscure tool to a highly capable AI system, what happens next?
Right, that's the big test.
The source text outlines two very distinct possible outcomes here, and they tell us everything we need to know about the system's actual intelligence. Let's look at outcome A.
Okay.
In outcome A, the AI system explores the interface. It forms hypotheses about what different functions might do based on context clues. It clicks a button, sees a result, tests that result, and when it gets an error, it revises its internal model of how the software works.
Like a human figuring it out.
Exactly. Over a period of time, through trial, error, and inference, it achieves working competence. If we see